Today we're going to be talking about big data.
How big is big?
Well, first of all, there is no precise definition at all. So kind of the standard, what people would say is when we can no longer reasonably deal with the data using traditional methods. So then we kind of think, what's a traditional method? Well, it might be, can we process the data on a single computer? Can we store the data on a single computer? And if we can't, then we're probably dealing with big data. So we need to have new methods in order to be able to handle and process this data.
As computers are getting faster and bigger capacities and more memory and things, the concept of what becomes big is changing, right?
So kind of, but a lot of it isn't really, as we'll talk about later, isn't how much power you can get in a single computer. It's more how we can use multiple computers to split the data up, process everything, and then draw it back, like in the MapReduce framework that we talked about before. With big data, there's something called the 5 Vs, which kind of defines some features and problems that are common amongst any big data things. We have the 5 Vs, and the first 3 that were defined, and I think these were defined in 2001, so that's kind of how long this has been talked about for. So first of all, we've got volume. So this is the most obvious one. It's just simply how large the data set is. The second one is velocity. So a lot of the time these days, huge amounts of data are being generated in a very short amount of time. So if you think of how much data Facebook is generating, people liking stuff, people uploading content, that's happening constantly all throughout the day. The amount of data they generate every day is just huge, basically. So they need to be able to process that in real time. And the third one is variety. Traditionally, the data we would have, and we would store it in a traditional single database, it would be in a very structured format. So you've got columns and rows, every row would have values for the columns. These days, we've got data coming in a lot of different formats. So as well as the traditional kind of structured data, we have unstructured data. So you've got stuff coming in like web stream clicks, we've got like social media likes coming in, we've got stuff like images and audio and video. So we need to be able to handle all these different types of data and extract what we need from them. And the fourth one is value.
Always important.
Yeah. So there's no point in us collecting huge amounts of data and then doing nothing with it. So we want to know what we want to obtain from the data and then think of ways to go about that. So some form of value could just be getting humans to understand what is happening in that data. So for example, if you have a fleet of lorries, they will all have telematics sensors in. They'll be collecting sensor data of what the lorries are doing. So it's of a lot of value to the fleet manager to then be able to easily visualize huge amounts of data coming in and see what is happening. So as well as processing and storing this stuff, we also want to be able to visualize it and show it to humans in an easily understandable format. Other value stuff is just finding patterns, machine learning algorithms from all of this data. Then the fifth and final one is veracity. This is basically how trustworthy the data is, how reliable it is. So we've got data coming in from a lot of different sources. So is it being generated with statistical bias? Are there missing values? If we're using, for example, sensor data, we need to realize that maybe the sensors are faulty, they're giving slightly off readings. So it's important to understand how reliable the data we're looking at is. So those are kind of the 5 standard features of big data. Some people try and add more. There's the 7 Vs of big data, the 10 Vs of big data I've seen. I'm sure it will keep going up and up. They add in things like vulnerability. So obviously when we're storing a lot of data, a lot of that is quite personal data, so making sure that that's secure. But these are kind of the 5 main ones. The first thing with big data, obviously, is just the sheer volume. So one way of dealing with this is to split the data across multiple computers. So you could think, okay, so we've got too much data to fit on one machine, we'll just get a more powerful computer, we'll get more CPU power, we'll get larger memory. That very quickly becomes quite difficult to manage because every time you need to scale it up again, because you've got even more data, you need to buy a new computer or just new hardware. So what tends to happen instead, and mostly all companies will just have like a cluster of computers. So rather than a single machine, they'll have, say, a massive warehouse basically filled with loads and loads and loads of computers. And what this means that we can do is we can do distributed storage. So each of those machines will store a portion of the data, and then we can also do the computation split across those machines. So rather than having one computer going through, 1 billion database records, you can have each computer going through 1,000 of those database records.
How do you split that up? Let me take a really naive way of saying, right, okay, let's do it alphabetically. A load more records come in for, say, Z. That's easy, you stick it on the end. A load more records come in for P. It's right in the middle, right? How do you manage that?
So there's computing frameworks that will help with this. So, for example, if you're storing data in a distributed fashion, then there's the Hadoop distributed file system, and that will manage kind of the cluster resources where the files are stored. Those frameworks will also provide fault tolerance and reliability. So if one of the nodes goes down, then you've not lost that data. There will have been some replication across other nodes, so that losing a single node isn't going to cause you a lot of problems. What using a cluster also allows you to do is whenever you want to scale it up, all you do is just add more computers into the network and you're done. And you can get by on relatively cheap hardware rather than having to keep buying a new supercomputer. In a big data system, there tends to be a pretty standard workflow. So the first thing you would want to do is have a method to ingest the data. Remember, we've got a huge variety of data coming in. It's all coming in from different sources. So we need a way to kind of aggregate this and move it on to further down the pipeline. So there's some frameworks for this. There's Apache Kafka and Apache Flume, for example, and loads of others as well. That will basically aggregate all the data and push it onto the rest of the system. So then the second thing that you probably want to do is store that data. So like we just spoke about, the distributed file system, you store this in a distributed manner across a cluster. Then you want to process this data. And you may skip out storage entirely. So in some cases, you may not want to store your data. You just want to process it, use it to update some machine learning model somewhere and then discard it. And we don't care about long-term storage. So yeah, processing the data, again, do it in a distributed fashion using frameworks such as MapReduce or Apache Spark. Designing the algorithms to do that processing requires a little bit more thought than maybe doing a traditional algorithm would. The frameworks will hide some of it, but you need to be thinking that even if we're doing it through a framework, we've still got data on different computers. If we need to share messages between these computers during the computation, it becomes quite expensive if we keep moving a lot of data across the network. So it's designing algorithms that limit data movement around, and it's the principle of data locality. So we want to keep the computation close to the data, don't move the data around. Sometimes it's unavoidable, but we limit it. So the other thing about processing is that there's different ways of doing it. So there's batch processing. So you already have all of your data, or whatever you've collected so far. You take all of that data across the cluster, you process all of that, get your results, and you're done. The other thing we can do is real-time processing. So again, because the velocity of the data is coming in, we don't want to constantly have to take all the data we've collected so far, process it, get results, and then we've got a ton more data. I want to do the same, get all the data, bring it back, process all of it. So instead, we would do real-time processing. So as each data item arrives, we process that. We don't have to look at all the data we've got so far. We just incrementally process everything. And that's coming up in another video when we talk about data streaming. So the other thing that you might want to do before processing is something called pre-processing. Remember I talked about unstructured data? So maybe getting that data into a format that we specifically can use for the purpose we want to. So that would be a stage in the pipeline before processing. The other thing with huge amounts of data, there's likely to be a lot of noise, a lot of outliers, so we can remove those. We can also remove redundant instances. So if you think we're getting a ton of instances in and we want a machine learning algorithm, there'll be a lot of those instances that are very, very similar. So yeah, an instance is, say, in a database, it's like a single line in the database. So for a HGV sensor reading, it would be everything for that lorry at that point in time. So yeah, speed, direction it's traveling. Reducing the number of instances is about reducing the granularity. So part of it is saying, if we store, rather than storing data for a continuous period of time, so every minute for an hour, if there's data very similar across that, we can just say, okay, for this period, this is what happened, and put it in a single line. Or we could say, for example, a machine learning algorithm, if there's instances with very, very similar features and then a very, very similar class, we can take a single one of those instances and that will suitably represent all of those instances. So we can very, very quickly reduce a huge data set down to a much smaller one by saying there's a lot of redundancy here. We don't need 100 very similar instances when one would do just as well.
So if you've got 100 instances and you reduce it down to one, does that not have an impact on how important those instances are in the scheme of things?
Yes, so techniques that deal with this stuff, some of them would just purely say, okay, now this is a single instance and that's all you ever know. Others of them would
have a weighting.
Have a weighting. So some way of saying this is a more important one because it's very similar to 100 others that we got rid of. This one's really not as important because there are only 3 others that were similar to it. So we can weight instances to kind of reflect their importance. There are specific frameworks for big data streaming as well. So there's technologies such as the Spark streaming module for Apache Spark, or there's newer ones such as Apache Flink that can be used to do that. So they kind of abstract away from the streaming aspects of it, so you can focus just on what you want to do rather than thinking all this data is coming through very fast.
Obviously my limited brain is thinking streaming relates to video, but you're talking about just data that is happening in real time, is that right?
Yes, so
as an example,
going back to the lorries, as they're driving down the motorway, they may be sending out a sensor reading every minute or so. And that sensor reading goes back. We get all the sensor readings from all the lorries coming in as a data stream. So that's kind of a very quick roundup of the basics of big data. There's a lot of applications of this, obviously. So banks will have huge volumes of transaction data. If they can extract patterns of value from that and see what is normal, they can do kind of fraud detection on that. Again, the previous example of fleet managers understanding what is going on. Basically, any industry will now have ways of being able to extract value from the data that they have. So in the next video, we're going to talk about data stream processing and more about how we actually deal with the problems that real-time data can present us. Over very, very large files, this kind of computation is a lot more efficient if you can distribute that. Because doing this map phase of saying, okay, this is one occurrence of the letter A, that's independent of anything else, and so you can split that across.
Most of which you're not interested in. You're probably only interested when a button's pressed or so on. The only times perhaps that's different